one of the reasons why we're going with CQRS for this application is because it's a proven way of getting really high scalability out of an application. So we're going to start with basic definition of CQRS. It's basically just separating reads from writes. When you separate reads from writes, then it opens the door to a lot of different architectural possibilities that were not possible before. When I say reads from writes, I mean when let's say we're going to create a new customer record. Um, the typical way of creating a customer is you create it and then you return something about that customer, like an ID, back to the client in the same call. CQRS says instead of doing that, you create the customer and you return nothing to the client, and then later on, when the customer is finally created, then you send a signal back to the client saying it was created. That's the idea behind CQRS, separating reads from writes. Some of the doors that opens for us are as follows. Look at the graphic that I'm showing you right now. We've got a user that has a client, and that client is going to be submitting a GET request to the API. The API can then go down to a denormalized database that is what we call a view model database, and this view model database maybe has one separate table or one view model, we would call it, per type of call on the data on the site. So let's say we're talking about Amazon.com, and there's a products page where you can view all the details for several products. So this denormalized view model database would have all 15 columns that are needed to populate the data on that page. This gives us, if we can do this without doing any kind of joins, if we can just do a select star from product view model where category is 12, that's a really fast query, especially if we're if we're indexing things properly and optimizing for gets for reads. So we should be able to return that back to the client to the client really fast, and we're talking like split second response here. So very low latency API. Or we could even take the API out of the picture and use something like CouchDB for the database, the view model database, and we can just have the client going directly to the view model database, because CouchDB basically has its own API. So that would even take out some more of the possible latency by having an API. So this pattern is allowing this kind of flexibility. All right, so that's the query side. Now we're going to talk about the command side. The commands are a little bit more complicated, or a lot more complicated, but it's all to facilitate this high scalability. So a command is anything that's not a read. So anything like as far as HTTP language, anything that's a post, a delete, a put, a patch, these are going to be commands, considered commands in this architecture. So the client is going to post something into the API. The API is going to take the payload from that post, and it's going to create what's called a command. Now in .NET, a command is just a regular old C# object. There's no logic. It's just got some public properties on it, and it's serializable. So we're going to serialize that command. We're going to stuff it into a queue. A queue is just a special type of database where it's got some methods where you can push something into the queue, and then something else can pull that same thing out of the queue. And the typical queue for this kind of thing is a first in, first out queue, so that things stay in the right order. Well, if you've posted a command, which is just a C# serialized object, maybe serialized to JSON or whatever, you push that into the queue, then that means that any number of worker servers or worker applications could pull from the queue your command. And then having the same domain logic in the worker, these workers would be able to process that command using what's called a command handler. The command handler would be responsible for doing all of the business logic, putting the data into the normalized database, the relational database, which is typically what we use. But then after it's done with that, it could then put a copy of the data into the denormalized view model database, which is what we talked about back in the query side. So as a result of the worker doing its work, we are updating the denormalized database also at the same time, or at least one after the other. Well, as you can imagine, this actually opens us up for a huge amount of scalability. Let's say we start with one worker, but then we decide that we're going to add another region or another country. We just add another worker, or as many workers as we need, thousands of workers possible. They're all reporting back to the same normalized database. And it doesn't matter how long the normalized database takes to respond or to do its work, because these workers are very patient and they're going to wait their turn. The whole time, the client has only received an OK. Their request has finished. So they posted from the client into the API. The API immediately returns an OK. So the client is not sitting with their browser spinning, waiting for all of this work to happen. They've already gotten an OK, and so it's a little bit of a change of paradigm as far as like in the UI, where typically if you create a new customer, then you want to see that new customer appear in the list of customers, maybe. Well, you can do that if you're using something like Durandal or Angular. You can do that and just do some JavaScript magic in the background, or you can just say to the customer, thanks. You can say to the client, thanks for this new thing that you just created. We'll let you know when it's finished. So let's talk about how that happens. So we've got the command. It goes into the queue. It goes to the worker, or the worker pulls the command out of the queue, and the worker is going to update the normalized database, then the denormalized database, and then we're going to have another thing that's going to happen over here. So the worker is going to, it all responds to events. So the worker can throw another event that basically sends a message up to the client and says, your customer that you just created is now ready. And so that can be done with Signal R. Your client could, after the command is issued, the client could query the server once every second or every few seconds to check to see if it's ready. Any number of possibilities there. Well, then, after all that's done, the client is back to normal. He's able to see his new customer. And that new customer is available to other users that need to be able to search for that, and they're able to do it super quick. At the same time, we've got all the history data for that new customer. We've got all the relational aspects of that customer that's here, available to do any kind of domain logic that we need. And that's pretty much it. That's the idea behind CQRS, or at least that's what CQRS makes available to us. It's really just as simple as separating your reads and writes if you want to implement CQRS. But then if you want to implement the things that it makes possible, then that's when you start talking about queues and workers and view model databases. So in this Fire Tower application, and also in Replay 20 that we're working on, we're going to be implementing this pattern. So separating reads from writes, using a queue, using workers, and using a denormalized view model database for reads. Have fun. If you have any questions, then ping me. Thanks.